All right, let's get excited for this one, ladies and gentlemen. We're talking about inverse trig today. So, I've mentioned how in this chapter there is just a lot of rules to memorize in terms of natural log and e to the x, and we're going to get into some other stuff. But today's lesson is about the derivative rules for inverse trig functions and then integration dealing with inverse trig functions. So, what I'm going to refer you to, I'm going to write these rules out, and I would encourage you to do it on your notes as well, because if you write them, you're more likely to remember them, obviously. But on the sheet I have given you with all the formulas up till now, the derivative rules for your inverse trig functions. Now remember, inverse trig can be written one of two ways. It could be written like arc sine, or you also might see it written as like sine inverse, or like I have here, like cosine inverse. Just knowing that those are synonyms, because they could show up either way on your test. So just knowing that that's what that means. So here they are to reference on your formula sheet. You will not be given this formula sheet for any tests or quizzes. You'll have to know these. So here are the derivative rules that we're going to have, which I'll write them down here in a second. And then here are the integration rules that we're going to have. Now, when I say dealing with inverse trig, we're not going to integrate inverse trig. We're going to integrate functions that lead us to inverse trig. Kind of like we differentiated natural log, but then we didn't integrate natural log. We integrated a function that got us natural log. So similar idea. I am going to start by saying this. These are topics that College Board says that you need to know. They are not questions that are going to show up a ton. I'll kind of point out, if there's an inverse trig question on the AP test, what it probably will be. At that point, it's going to be up to you how much time you want to spend memorizing these rules, or, again, that's just completely up to you. So I'm going to list out these rules, and then that way you can also write them down. So the derivative for arc sine of u being some function of x, is this. Y prime equals u prime, so whatever the derivative of the inside is, over the square root of 1 minus u squared. That's your rule. So whatever is inside the inverse sine function, you differentiate it, that goes up here. Whatever's inside it, you square it, goes down here. And we just write it in that form. The derivative of inverse cosine is negative u prime over square root of 1 minus u squared. So it's the same rule, but this one's negative. And you'll find that happens for the other three functions, that it's the same rule, but one of them is always going to be negative. So that's kind of nice, kind of limits the memorization. The derivative of arctangent of u is going to be u prime over 1 plus u squared. So it takes out the square root, it's positive, it's kind of the most nice looking. The derivative of arc cotangent, so inverse cotangent, is negative u prime over 1 plus u squared. So same rule, arc cotangent is negative. The last two, the derivative of inverse secant is going to be u prime over u times the square root of u squared minus 1. And then arc cosecant, the derivative is negative u prime over u square root of u squared minus 1. Those two are nasty. I can say with a good amount of certainty that you're probably not going to be having to do problems like this. You're not going to have to memorize these formulas here. I'll let you in on a little secret. I don't have these formulas memorized, nor do I really intend to ever do it. I don't have to take the AP test, which is not a great thing to say, but you'll have to make that decision on how much time you want to spend memorizing these formulas that might show up one time. If you're aiming for 100% on the AP test, then knock yourself out. That's up to you. So the one you're most likely to see is, and I'll talk about this with integration, maybe arctangent. And the nice thing is that's the one that's kind of the nicest looking. There's no square root. It's all positive. This is the one that I would make sure we know, possibly arcsine. I mean, those are the two that they kind of stick with that I've seen on the AP test. If they do show up, it's typically arcsine and arctangent. The other ones they say you need to know, I've never seen it show up anywhere. So I'm going to do a couple examples. Like I just said, the two you probably need to know the most are arcsine and arctangent. So I have examples with arcsine and arctangent. So if y equals arcsine of 2x, or sine inverse of 2x, find y prime. Well, our rule for arcsine, the derivative is, I always like to write the rule when I learn it, u prime over square root of 1 minus u squared. So in this problem, our u is 2x. We're not doing really u substitution like integration, but it's just good to identify, since the formulas all have u's in them, well, let's just deal with u. U prime is the derivative of that. So in this problem, u prime equals the derivative of u, so in this case 2, over square root of 1 minus, and then it's going to be whatever u is squared. So we're squaring 2x, so we get 4x squared. That is our derivative of arcsine of 2x right there. So they're pretty easy to use, but hard to remember. So again, just depends how much time you want to spend remembering them. If y equals tangent inverse of x, find y prime. Well, the derivative of arctangent, if you will recall from 2 minutes ago, is going to be u prime over 1 plus u squared. So in this case, our u is just x, which is kind of nice. When it's just x, it works out rather nicely. So y prime equals, well, the derivative of x is 1, and then over 1 plus, and then x is our u, so x squared. I did this one on purpose because I want you to recognize this for when we start getting into integration. You'll see what I mean, but I want us to be able to recognize 1 over 1 plus x squared. Okay, you'll see what I mean coming up here. But those are our derivative rules. Now, the nice thing with integration is there's only 3 of them that you'll need to know, and really one of them you won't need to bother with that I'll talk about. So when we are integrating, I showed you on that pink sheet, here are our rules. If you are integrating 1 over a squared plus u squared, now a is just a number, so it could be like 1 over 4 plus x squared, so like a would be 2. A is just a number. U is our function of x. So if we see this form, then it's going to be 1 over a, so whatever that, if that was 4 right here, that would be 1 over 2. And then tangent inverse, or arctangent, of u over a plus c. So notice that in the formula, it's like the square roots of these things that you see on bottom. It's the square root of a here and here, and it's the square root of u squared that goes here. If I see this form, 1 over square root of a squared minus u squared, it's kind of just recognizing like the form it's in. I recognize this one as inverse sine. So this one is sine inverse, or arcsine, of u over a plus c. The last one, I'd be willing to bet you'll never see, but here it is. 1 over, and then u times square root of a squared minus u squared is 1 over a secant inverse of the absolute value of u over a plus c. So not only is it the messiest looking inside the integral, it also has this absolute value here. It's secant, probably the worst one, but I've never seen that show up. So again, it's up to you. Okay, probably what you're most likely to see, because I've seen this one show up a few times over the past several years, is this right here, is the integration of 1 over 1 plus x squared. we learned some integration strategies. We learn how, I'm going to write some stuff over here. You choose to write it if you want to or not. We've learned how if I gave you something with the same degree, right here, if you have the same degree on top and bottom, or if the top is bigger, then we do long division to get it into a different integral that we can then integrate. So if the top is bigger or same degree, division. If you have something like this, where if I had x over 1 plus x squared, if I had this is a prime candidate for u substitution, because I've said have u be something where its derivative shows up somewhere else. If I had u be 1 plus x squared, the derivative is 2x, and there's an x right here. This one, I can do u substitution. But if I look at the example I gave, I can't do u substitution. Because if I have u be 1 plus x squared, the derivative is 2x, and then there's an extra x that I don't have on top or anywhere else. So what I'm trying to get at is I want you to look at the difference between u substitution, when you see x squared on bottom, and when I can't do u substitution right here, okay? U sub, can't do u sub. So I think that's important in this lesson. I don't like memorizing rules, but I think this is important to recognize, like, how do you attack an integral problem? Well, so over here I can't do u substitution. I have to recognize this as the inverse tangent integral. This is the one you're most likely to see. So if I take you back here, 1 over some constant squared plus some function of x squared, that's what I have right here. I have 1 over some constant squared plus some function of x squared. It's in the form I need it to be. And basically, a is 1 and u is x. It's this a and u are the square roots of these things. So if a is 1 and u is x, and I look at this form right here, so it's going to be 1 over 1, so 1, tangent inverse, and then it's u, which is just x in this problem, over a, which is just 1, so tangent inverse of x plus c. This right here is probably one you're going to want to recognize. And that's why on the other part of the notes, if I differentiate tangent inverse, I get 1 over 1 plus x squared. Well, that means if I integrate 1 over 1 plus x squared, I get back to tangent inverse of x. So I just wanted to show you guys that kind of back and forth right there. This is the one that I would star and make sure you can recognize that. I'm not telling you not to memorize the other ones and practice the other ones, because you're going to have to on the homework and stuff. But again, that's up to you. So I'm going to do one more, because on your homework, you're probably going to have to do some u substitution with this. It's not just going to be like, oh, I see that, and then my answer is this. You're probably going to have to do some form of u substitution. So if I assign it, I should probably show you an example of what I mean. So I'm going to add one more example here. If I want to integrate 4 over 1 plus 9x squared. So before I just dive in, I think about a couple of things. I think, can u substitution work right off the bat? No, because the derivative of the whole bottom is 18x, and there's no x up here. I'm stuck. Now I have to think, oh, we have these inverse trig rules. Maybe it's one of those. And then I just think, which one is it most closely related to? Do I notice? There's no square roots. I have a constant squared, and I have a function of x squared. So this is this. And so that's the first thing, is just identifying what does it match up with. Okay. Personally, when I have constant multiples, I pull them out. I would pull that 4 out right off the bat and just not deal with it throughout my work. This is not necessary, but I think it's very helpful. Okay. The next thing we want to do is identify a and u, what a and u are. Well, a squared is 1, and u squared, this part right here, u squared, that whole term, is 9x squared. That means a is 1, and u is 3x. And we are doing a form of u substitution here, because we're going to change this to be 1 plus u squared, which means we have to get rid of the dx. We're going through our u substitution process. So think about when we do u substitution, we get here, and then we differentiate it. Du equals 3 dx. And now I'm trying to replace dx right here. So divide by 3. Okay, so I already had a 4 out in front. Now I'm going to have a 1/3 out in front. So I'm going to have 4/3 when I do my u sub substitution. I'm going to have 4/3 out in front. The integral of 1 over, well, a is just 1, so it's going to be 1. A squared is 1. Plus u squared du. Notice I basically wanted to get it into the form of 1 over 1 plus x squared. That's the biggie that we have to recognize, and that's what I was trying to get to right here. Now that I'm there, my answer is just arctangent of u. So it's 4/3, and then arctangent of u plus c. That's the lunch bell. So I'm about to go eat some lunch after I write this answer. So u is 3x plus c. All right, probably my least favorite lesson. I probably shouldn't admit that, but probably my least favorite lesson of the year. But this is, like I said, this is the one I would make sure you guys can see. Notice the difference in your integration strategies. I think that's super important. How much time you want to memorize, that's up to you. Best of luck.